Hello and welcome to the second film in our Building Bases series. In it, we take a look at the various loads acting on the base of a building. Humidity and precipitation in the form of fog, rain, snow and meltwater hit the building shell and run down it. Rainwater falling on the surface of the surrounding ground splashes up onto the exterior walls. All this means that damp has a greater impact at the base of a building than at any other point in its shell and can result in damage to the building, as you can see on the left here. Damp also places a strain on the parts of a building that are underground. Rainwater seeping into the ground, standing, surface, and vadose water and groundwater all have an impact on the parts of a structure beneath ground level. The challenge is to prevent this water from penetrating the building fabric. In Northern Europe, the effect of winter cold on building shells is very significant, and shells must therefore provide heat insulation. Two different temperature levels meet at the base of a building because the external air around the building is colder than the ground temperature. At anything below 80 to 120 centimeters below the surface, temperatures remain above freezing point irrespective of the external air temperature, so that the thermal insulation characteristics demanded of the shell underground are lower. Depending on the use of a building, its base may also be subject to high mechanical loads. On the right here, you can see the depot we built for the Leipzig Municipal Environment and Waste Department. The vehicles at work here and the heavy objects that are moved present a significant risk of damage. The materials we used to construct the building base here were therefore stronger than those employed at the Rutli School in Berlin, shown here on the left for example, which is constructed using prefabricated reinforced concrete units. The construction of a building base has a considerable impact on the design of the facade. A comparison of our Provost Church in Leipzig and Chemnitz Police Station shows that the relationship between the base and the facing skin can produce very different effects. The building shown on the left is set in the ground, while the facade of the building on the right appears to float above it. Summary: precipitation and spray create a greater humidity load at the base of a building than at any other point on the building shell. In cold winters in particular, two different temperature levels meet at the base of a building where the exterior air is colder than the ground temperature. As a result, the insulating characteristics demanded of the shell are lower at the base. Depending on the use of a building, its base may also be subject to high mechanical loads, due to vehicle collisions, for example, and so require the use of stronger materials. The construction of the base of a building has a considerable impact on the design of the facade. Please take a look at the third film in our Building Bases series. In it, we explain the design principles that apply to the construction of the base for a building with double-skin masonry walls.